this last problem here, notice we have two parabolas. So again, let's do a mock-up for both of the two parabolas. On the first parabola here, notice to graph that first parabola, it is shifted to the right 2 and up 3. And there's a stretch of 1 in the upward direction. So I'm also going to draw that graph on my final graph down at the bottom without any shading. Notice I went ahead and drew it as a solid graph because it's an equal to. The question is which side of the graph to shade. Again, no way around it. You have to test a point. Let's test 0, 0, seeing as it's not on our graph. So plug in 0 for y and 0 for x. What will happen is you'll end up with 0 is greater than or equal to. We end up with, for this first part, a negative 2 squared, which is 4, plus the 3 that's on the outside, which is a total of 7. Is 0 greater than or equal to 7? Absolutely not. So 0, 0 does not work. So that means for this first parabola, at least, we're going to be shading the inside. Now let's look at our second parabola. Our second parabola here, we can do by shifting and stretching as well, is notice it's also a solid parabola. It's shifted to the right 1 and then up 6. 1, 2, 3, 4, 5, 6. So it's somewhere over here. Up at 1, 6. And then notice, though, the negative sign means that the stretch is going to be in the downward direction, meaning it's going to be flipped over. So again, I'll draw that on both of my graphs. Over 1 and up 1, 2, 3, 4, 5, 6. With the flipped over parabola. Again, I can still use the same point 0, 0 to test. So let's plug in 0 for x and 0 for y and see what happens. Notice we'll end up with 0 is less than or equal to, and on this first part, we're going to have 0 minus 1, which is negative 1 squared. Well, negative 1 squared will give you 1. Be careful, though. There is a negative out in front, which will make that 1 turn back into a negative. But then plus the 6 will turn you back into 5. Plus that 6 will turn you back into 5. So is 0 less than or equal to 5? Absolutely it is. So 0, 0 does work for our second parabola, which means I'm going to shade the inside of the parabola where 0, 0 is. So let's see what that looks like. Shading the inside of the parabola where 0, 0 is, because it does actually work for the second one. So let's see. Notice, now I need to shade my final graph, which is just the overlap. The overlap, notice, is just this interior part where the two parabolas intersect. That's the only part that should be shaded in my final answer. So that's when I'm going to go down into my final graph and just shade that section in between. And I'm all done, and that's the main idea behind your inequalities graphing and shading.